So Ohm's law states in a circuit, if you are giving some voltage or potential difference, then you will get the current. That current is directly proportional to the voltage applied. Have you understood? Hello?
Yes, sir.
Like you have a lamp. In a circuit, you have a lamp. Across this lamp, you have voltage applied. Now, the current will be depending on this voltage. If you are increasing the voltage, the current will also be increased. If you decrease the voltage, the current will also be decreased. Is it clear? Hello?
Yes, sir.
Like for example, you are giving 6 volt current, 6 volt voltage you are giving across a lamp, then you are getting 2 amps. How much you are getting? The current you are getting 2 amperes. Is it clear?
Yes, sir.
Then if we are giving 12 volt, what will be the current?
Sir, 4.
Yes, very good. 4 amperes. If you are giving 3 volt, the voltage is 3 volt, then
0.5
zero point 0.5 or
current.
1,
1, sir, 1.
1 amperes. If you are giving 1.5 volt, then it is 0.5 ampere. This way Ohm's law work. But there is a condition. The condition is in Ohm's law, it stated that the temperature limitation is there. That means for this law to be working, we need to fix the temperature. The temperature of the surroundings and temperature of the system, temperature of the circuit should be constant. Otherwise, this law will not work. Is it clear?
Yes, sir.
Hello, what about others?
Yes, sir.
Yeah, uh, we have with us Farabi, then Adrita as well. So, have you understood?
Yes.
Okay, we will link this idea, Ohm's law, with this learning outcome M, where we have an experiment to understand it. And actually, Ohm's law came from this experiment. This law, how it is working, we can understand it better from this experiment. Though it is not possible to show you the experiment now, however, we have the description of the experiment, and we have the diagram with the related components so that you can understand it. With these two learning outcomes, we have another learning outcome, that is Q. It's written here, describe the effect of temperature increase on the resistance of a resistor and a filament lamp, and draw the respective sketch graphs of current or voltage, current versus voltage. Now, this one is defying this law. You see, Ohm's law, we got the temperature remains constant, but here in Q, we are getting the temperature is not fixed. Temperature, if temperature increases, then how it works, the graph, how it works. In H, we will see sorry, not H, in M and N, we will see how this law is working with a graph, and in Q also we will see how the graph will be if the temperature is not constant, temperature is increasing. So let's go, let's start the law. First you write the statement of Ohm's law. We are directly going to the law. Are you seeing the screen? Hello?
Yes, sir.
So this law you have to write. Please write on your copy. Whatever is written here in statement, you write it. The mathematical writings, V is directly proportional to I. That one also you write. V equals IR, and this leveling, yeah, and this description you have to write. Where I is the current, V is potential difference, R is the proportionality constant, which is also known as the resistance of the conductor. Resistance is measured in ohms. So are you seeing the diagram? Sorry,
Yes,
are
sir.
you seeing the screen? So write it.
Yes,
Huh?
sir.
Current through a conductor is directly proportional to the potential difference across it, provided the temperature of the conductor remains constant. In numerically, you write V is directly proportional to I. So V equals IR, where I is the current, V is potential difference, and R is the proportionality constant, which is also known as the resistance of the conductor. Resistance is measured in ohms. About resistance, we will write something more here. You also write that. Lamisa, welcome back. Resistance is is an electrical property Lamisa. Hello, Lamisa.
Yes, sir.
Welcome back.
Oh, sir.
Yeah, Lamisa, what about your friends, Maimuna and Mariam? Did you talk to them?
Yes, sir. I talked to them and they're having a problem. They can't join.
They can't join today.
No, sir.
Okay. Thank you for taking the information. So tell them to check the recordings. Okay.
Okay, sir.
Resistance is an electrical property which opposes flow of electrons. In short, flow of electrons we know as electric current, right?
Yes, sir.
So have you understood it, the writing? Resistance is an electrical property which opposes flow of electrons. Generally, all the conductor wires have some resistance depending on their length and cross-sectional area.
Sir, what does cross-sectional area mean?
So you write here in bracket beside cross-sectional area, that is thickness. Now you understood,
Yes, sir.
like how thinner or how thicker it is. That is called cross-sectional area. If
Okay, sir.
if the cross-sectional area is more, then the wire is thick, right?
Yes, sir.
Okay, so you understood it, right? So till here, any questions? Do you have any questions?
No, sir.
Okay, fine. Now we need to have a very important decision to take about the timing, but unfortunately, Maimuna and Mariam is not here. So without them, if Lamisa, you help us. Hello, Lamisa.
Yes, sir.
Lamisa, you and Maimuna Mariam are doing the same way all the batches, right? Hello,
Yes.
in all the batches, like you and Mariam Maimuna are doing the same way, right? Your timing is same,
Yes, sir. Yes, sir.
and they are taking the subjects in their O level October November. You are taking the same subjects, or they are taking some extra.
So I dropped chemistry, so they're like the chemistry is the extra one they're doing.
And what about English?
So we give that exam already.
They also gave, right?
Yes, sir. But Maimuna didn't. Maimuna will give physics, maths, and biology and chemistry together.
Okay, so there is, routine clashing with chemistry maybe. So if they were present here, then it would be better for us to continue the discussion. Could you please tell them somehow to manage the data, mobile
So I
data?
can
Yeah,
routine
yeah,
from them now.
yeah, mobile data to use them for a while so that they can connect us and we can decide the timing, new timing. I have
Okay, sir.
I have one option for you all. You think of it. Huh? I am giving you time. You can give me the feedback on next class Saturday. By this time, you have a discussion with your friends. Okay, Lamisa. And for you all, I am giving the proposal that is on Monday and Wednesday. On Monday and Wednesday, uh, we have one slot that is from 8:45 p.m. night, huh? 8:45 to 10:15. This slot I can give you for you
Sir,
all.
I can.
For
Sir,
you
on
all,
Monday.
for
That's a weekend.
for you all, we are offering it. Okay, so you check it out. That you have any other class?
Sir.
Yeah,
So
Lamisa,
I have a problem actually.
you have class?
Yes, sir. Actually, there is a Mujib sir class from 4 to 6, and after that, I have a class of like I have a student actually, so I just I can't.
You have a
So
student both the days, Monday and Wednesday.
Yes, sir. Monday is like ওই student থেকে স্যার মানডেতে মারিয়াম পড়ায় and Wednesday তে আমি.
So which time you teach?
Sir, I teach like in 7 to 9.
So it's marginal. You can manage 15 minutes, right? Like we are starting almost 9, 8:45. So
Oh,
you
yes,
just
yes, yes.
little bit
I
you
can do
just
that.
shift it. Okay.
Yes, sir.
Ah,
Excuse me, sir.
8:45 to 10:15.
Sir,
Yeah. Hello.
I have a class on Monday from 9 to 10.
Okay. You have a class 9 to 10 on Monday.
Yes.
Okay.
And on Wednesday, I have a class from 8:30 to 9:30. I can shift the class on Wednesday, but that on Monday, the teacher cannot shift it.
Hmm. So it will not work. This timing will not work actually for you, right? So will it be possible like Monday and Wednesday? Can we make it in the afternoon timing? Hello?
Sorry, your voice is lagging.
Mhm. I'm saying, I'm repeating, like Monday, like the time I proposed, that one is not working, right? Because Adrita has class, right, on Monday. Hello.
Yes, sir.
So can we do it in the afternoon, Monday and Wednesday? Like we start 5 to 6:30. Will it be okay?
So in Monday
Sir,
5
I
to
have
6:30.
at Wednesday class at 6.
Which time? Monday?
Sir, Wednesday at 6.
Wednesday at 6. Okay. 5 to 6:30.
So
Then
I also have a class in that time.
which time?
So so at 5 till 6:30.
5 till 6:30. Okay. Okay. So on Saturday and Thursday, if we do it 5 to 6:30, then
Sir, I have class till 5:30.
Sir, I have a class on Thursday from 4:30 to 6.
okay.
So I also have a class in Thursday 5 to 6.
Okay. So is it possible Saturday and Thursday 8:45 to 10:15?
For me, yes.
Let me.
Okay for me.
It's all right for you?
Yes.
Sir, it is all right.
Yes, sir.
Yes, sir.
Okay, so this is proposed. Actually, I have another batch at the same time, Thursday and Saturday. If I can shift them in another place, then it is possible for you to go in that slot, 8:45 to 10:15, Saturday and Thursday. Okay. Hello.
Okay.
So we will discuss with them the matter. Today we have class 8:45, and then we will tell you on Saturday. We will finalize it. Okay.
Okay, sir.
Is it clear?
Yes, sir.
Okay. Okay. Then we go for some more discussion on Ohm's law. This part is done. About the experiment, we we have an arrangement like this. Are you seeing the diagram? Hello.
Yes, sir.
So Farabi, you read it. You read the experiment from the beginning.
Experiment to understand Ohm's law. Aim to verify the Ohm's law and hence determine the unknown resistance of the given material of the wire. Apparatus, a battery, an ammeter, voltmeter, rheostat, variable resistor, a resistor whose resistance can be varied. Plug key, switch, coil of unknown substance, fixed resistor, connecting wire, etc.
Okay, so you see the circuit diagram. We have here E. E is the cell. K is the key. RH. This one is the variable resistor. In short, it is called rheostat. That's why that is written RH. Then R. R is the resistor, fixed resistor. We have a voltmeter connected parallel to the resistor, and we have an ammeter to measure the current. You see here in this circuit we are having an ammeter connected in series in the circuit, and the voltmeter is connected in parallel. Okay, so Maimuna, Maimuna, oh, Maimuna is not there. Mariam, Mariam, have you joined? Hello, I saw Mariam. No, she is not connected. She couldn't connect. Okay, fine.
Sir, what is rheostat?
Yeah,
Sir, they
rheostat.
are
Yeah, say Lamisa.
so they were trying to join but like
Yeah, yeah.
can't.
Dropped. It dropped. The network dropped, right? So rheostat, very good question. Rheostat, like Mahi Khan, you might have another name, right? Do you have any
Yes,
nickname?
sir. Yes, sir.
What?
Sir Abdullah.
Abdullah. Okay. So, like that, rheostat is variable resistor's nickname. Got it?
Yes, sir. Got it.
Variable resistor means the resistance we can vary. That one, in short, it is called rheostat. Is it
Okay.
clear?
Yes, sir. Clear.
Okay. Thank you for your questioning. Now, you see steps. We have here some steps. Can you read them, Mahi?
Okay, sir. Steps number one, the circuit is connected as per circuit diagram. Number two, the plug key is inserted and the rheostat is adjusted so that a definite amount of current I flows in the circuit. Number three, as the current flow through the unknown resistance R, a potential difference is developed which is read from voltmeter V. Number four, the procedure is again adjusted to a different value of current I and the corresponding uh, potential difference voltage values are noted down, at least 5 to 6 readings. Readings are recorded in a table. Number 5, graph of volt against current is drawn. A straight line is obtained. Number 6, the gradient slope of the graph is calculated, which gives the resistance R of the unknown resistor.
Okay, so here is the graph. Like we had this readings, 5 readings. For V, we got 2, 4, 6, 8, 10 volt. We varied it. When we are changing the resistance of the rheostat, we are you say we can slide it, huh? Left to right we can slide. So when we are sliding it left, then the resistance of the rheostat is less. Got it? Hello?
Yes, sir.
So if the resistance is less, the current will be more in the circuit, right? Hello?
Yes, sir.
And current is more, and across this resistor, the voltage is also more. That one is shown here in this data. You see the table. If the voltage is 2 in the voltmeter, the current is 1 ampere. The voltage is 4, the current is 2. Voltage is 6, current is 3. This way, we are having 5 readings and we are plotting the graph. You see here, voltage versus current. This is called VI graph. VI graph, voltage versus current graph. And we have here these readings are plotted on the graph. You see the first reading here, second reading point, 5 points are here. So we are getting one straight line over here. That means voltage and current is directly proportional. If we are getting the gradient, V gradient is here V over I, right? Hello?
Yes, sir.
For any points, any of the points, if you are taking the gradient like 10 by 5, it's coming 2 ohms, right? 10 by 5, we got the formula V equals IR, right?
Yes, sir.
So V by I, it is the gradient. Then V by I is coming for all the readings is coming 2 ohms. 2, right?
Yes, sir.
So V by I is giving us the resistance. Thus, using this experiment, we understand two things. That is, voltage is directly proportional to the current, right?
Sir, how do we get the readings?
Readings we are getting in the appliance. You see here, we connected one ammeter. Ammeter is an instrument to measure the current, right?
Yes, sir.
And voltmeter is the instrument to get the voltage, right?
Yes, sir.
So we are actually getting the current through this resistor. This current is same everywhere, right? It is series circuit, so there is a single path, so everywhere the current is same, right?
Yes, sir.
So the current reading we are getting here in the ammeter, that is also the current reading for this resistor, fixed resistor, isn't it?
Yes, sir.
So the current we are getting for the fixed resistor, the voltage we are getting for the fixed resistor, from here in the voltmeter and from the ammeter. Is it clear? From ammeter we are
No,
getting
sir.
current reading. From the voltmeter we are getting the potential
Voltage.
difference reading. Got it?
Oh, yes, sir. Now I understand.
Yeah, like by changing the position of the rheostat here, if you bring it in the left side, right side, then we can get less current or more current, right? Because we are increasing and decreasing the resistance in the circuit. That's why the current will be different, right? Isn't
Yes,
it?
sir.
And voltage across this resistor will be also different. That's why we are getting different readings while we are changing the rheostat. Is it clear now?
Yes, sir. Clear.
Okay. Any more questions, anyone? Hello? Hello?
No, sir.
So you all understood this? Hello?
Yes, sir.
Okay, so if you all understood it, then you draw this circuit only. Huh? You you write here experiment to understand Ohm's law. After writing this heading, you only draw the circuit. Okay. You write here circuit diagram for Ohm's law experiment. Circuit diagram for Ohm's law experiment. You draw this diagram. Let me know once you are done. Huh? Are you done with the circuit? Hello?
No, sir.
Do it, huh?
No, sir.
I am sending it in the group. They who are not done, you take it from the group. Yeah, it's there in the group, huh? They who are not done with the circuit diagram, you complete it from the group. Then after this circuit diagram, you only draw the graph. Huh? You do not need to write all these steps. Those are available in the group notes. So when you need it, you check it from the notes. In our Google Classroom, it's available. So you draw this graph. This is mandatory. You have to draw this graph. Oh. I'm also sending you the graph so that you can take it from in the group. So graph is also there in the group. Okay.
Okay, sir.
Hello. So you can take it. So we are done till here today. We got the idea of Ohm's law and the experiment related to Ohm's law. Is it clear, everyone?
Yes, sir.
In our next class, we will discuss another one. That one is linked with Ohm's law and where the temperature is not constant. For Ohm's law, we need the temperature to be constant. For this graph to be drawn or to get these readings this way, we must need to have the temperature constant. But if the temperature is not constant, then the graph will not be straight. That will be like this curve. That one we'll discuss in our next class. Why it is curve. Okay, got it, everyone?
Okay, sir.
So that's all for today, huh, everyone? Thank you so much. Thank you so
Thank you,
much,
sir.
and
Thank you, sir.
for your cooperation, patience. We will fix the time, inshallah. Okay, on Saturday. Allah Hafiz, huh? Don't worry.